Welcome to Physics in Motion. Today, we're diving into the bedrock of classical mechanics, Newton's laws of motion. These three laws govern everything from falling apples to orbiting planets. Let's unravel them. Newton's first law, the law of inertia. An object at rest stays at rest. An object in motion stays in motion, unless acted upon by an unbalanced force. Inertia is the resistance to change, whether you're a parked car or a comet hurtling through space. Remember, no net force? No change in motion. Newton's second law, the force equation. Force equals mass times acceleration. F equals ma. This is the engine of motion. Push a shopping cart lightly, and it accelerates slowly. Push it harder, and it zooms. Mass resists acceleration, force overcomes it. The bigger the mass, the more force you need. Simple math, profound implications. Newton's third law, action-reaction. For every action, there is an equal and opposite reaction. Step off a boat? It pushes back. Rockets ignite fuel downward. The thrust propels them upward. Forces always come in pairs, equal in magnitude, opposite in direction. No exceptions. So there you have it, inertia, force, and action-reaction, the trio that shapes our universe. Today, we return to the bedrock of classical mechanics, Newton's first law, the law of inertia. This isn't just a rule, it's the universe's stubborn refusal to change without reason. Listen closely to nature's decree. An object at rest stays at rest. An object in motion stays in motion, unless acted upon by an external force. This simple statement shattered ancient myths about motion. Aristotle believed objects wanted to stop. Newton proved, inaction is the default state of matter. Consider this book on a table. It sits motionless, not because it lacks desire to move, but because all forces balance perfectly. Gravity pulls it down, the table pushes it up. Net force? Zero. And so, like a sleeping giant, it remains at rest. Forever, unless you disturb it. Mathematically, we distill this into elegance. When net force sums to zero, acceleration vanishes. Velocity becomes constant. And this stubbornness? Inertia. The tendency of matter to resist changes in motion. Mass isn't just stuff, it's a quantitative measure of inertia. A freight train resists acceleration more than a bicycle. Physix poetic justice. So remember, motion persists, rest endures, until forces intervene. Next, we'll see how Newton's second law forces change upon this stubborn universe. Now, we unlock the engine of motion, Newton's second law. This elegant equation, F equals ma, is the golden key to understanding how forces shape our universe. Let's dive in. Here's the core truth, acceleration depends on two things. First, it's directly proportional to the net force acting on an object. Push harder, accelerate faster. Second, it's inversely proportional to mass. Heavier objects resist acceleration. Think of kicking a soccer ball versus a boulder. Same force? Wildly different results. Watch this play out. When we double the force, F to F, acceleration doubles. Triple the force, 3F, acceleration triples. This is why rockets need monstrous thrust to overcome inertia and leap toward the stars. Now, flip the script. What if force stays constant but mass increases? At mass m, solid acceleration. At double the mass, 2m, acceleration halves. At triple the mass, 3m, just a third of the acceleration. That's why you can't push a car as fast as a bicycle. Let's crystallize this mathematically. Acceleration proportional to force. F but inversely with mass m at a proportionality constant. But in SI units? K equals 1, collapsing into the iconic F equals ma. This tiny equation, just 3 symbols, powers everything from falling apples to Mars landings. So remember, force ignites motion, mass resists it, and F equals ma tames the chaos into predictability. We've seen how forces create motion and mass resists it. Now, prepare for physics' most elegant symmetry, Newton's third law. This isn't just a rule, it's the universe's ultimate balancing act. Here's the heartbeat of this law. For every action, there is always an equal and opposite reaction. Notice, equal means same strength. Opposite means mirror direction. Always means no exceptions, from subatomic particles to colliding galaxies. Watch closely. When you jump off a boat, our foot pushes backward on the boat, action. Instantly, the boat pushes forward on you, reaction. That's why you land on the dock, while the boat drifts away. One force, two objects, perfect balance. Now, scale it up, rocket propulsion. The rocket violently expels exhaust downward, action. And the exhaust hurls the rocket upward, reaction. No magic, just Newton's third law conquering gravity. Mathematically, we write F12 equal 2 negative F21. Force of object 1 on 2 equals force of object 2 on 1. Remember these pillars. Forces act on different objects, never cancel on one body. They're equal in magnitude, mirror strength, but opposite in direction, 180 degrees apart, and they're simultaneous, no delay, instant cosmic dance. So remember, physics is a conversation. Every push gets a mirrored push, a cosmic partnership shaping everything from walking to spaceflight. Next time, we'll see how all three laws unite in everyday life. Until then, stay balanced, stay curious. This is Physics in Motion. Like, subscribe, and hit the bell for more mind-bending science. Until next time.